Roads and highways are arteries through which the economy pulses. By linking producers to markets, workers to jobs, students to schools, and the sick to hospitals, this infrastructure is vital to the development and growth of every nation. In an organization, information technology infrastructure plays a very same role to road networks. In this video presentation, we will have a closer look at IT infrastructure and its related emerging technologies. Like road architecture, the design of IT infrastructure is crucial to its stability and reliability. For it to support the timely demand of information of its clients, it must allow continuous flow of data without interruption. But what if the IT infrastructure is designed inappropriately, such as under capacity to accommodate an increasing volume of data processing, or data traffic congestion, or unsecured and incorrect routing? Yes, the same with roads. This would entail poor direction, planning, and control within the organization, resulting to chaos, unmanaged risk, and in the worst case, leads to its downfall. As managers and future leaders of our own companies, this video is meant to teach us the very basic things of IT infrastructure that we should know. What is IT infrastructure?
Hello guys, this is Charles Katipay. In this part of the presentation, I will be defining what IT infrastructure is and its components. So, IT infrastructure or information technology infrastructure refers to the various or set of components required to run information technology and data-driven operations. So, it can be connoted as the backbone of your organization's entire operations. This infrastructure enables organizations to efficiently deliver services and solutions to its customers, suppliers, partners, employees, and to its top management. These three icons up here are the symbols of the basic components of IT infrastructure. We have software, hardware, and network. A software is a set of instructions, data, or programs used to operate computers and execute a specific task. It basically tells the computer how to work. You cannot feel it, you cannot see it, but it's always there in your computer. Softwares often fall into two categories. However, we have other classifications such as middleware, firmware, and utilities. These two main classifications of softwares are application programs or the application software and the system software or your operating system. Application software refers to user downloadable programs that fulfill a want or a need, such as word processor, spreadsheets, PowerPoint. This app that I used in editing videos, Filmora. You have your games, you have YouTube, you have the web browsers, basically anything that you can see on the desktop of your computer or on your cell phone. On the other hand, system software is the operating system that supports the computer's basic function, such as executing this or the previously mentioned application softwares and controlling peripherals such as printers, mouse, or keyboard. This is, again, basically your computer's operating system like Windows or Mac OS, or in your cell phone you have Android or iOS. It is often passively running without much intervention with the end users, and it is running at the most basic level of the computer. The other types of softwares are middlewares and firmwares. Middleware, as its name connotes, refers to programs that mediate between an operating system and application softwares. It acts as a translator, facilitating data exchange and communication between an operating system and the application software. Basically, it functions as a support to the application software by providing it services that cannot be provided by the operating system. While firmware refers to permanently programmed software that is installed into a read-only memory of the device, which allows users to control the hardware of the device. For example, mouse, keyboard, printers have firmwares. The central processing unit has this so-called BIOS, or basic input-output system, that tells it to start the computer once you turn your computer on. So from the time you press the power button of your computer to the time that the logo of your operating system shows on your screen, it's the operation of the BIOS. On the other hand, we have hardware and network. These two components are considered as the framework of IT infrastructure. In comparison to the human body, the software can be compared to the body's nervous system, while hardware and network can be compared to the skeletal, muscular, circulatory, and respiratory as well, that support the physical and physiological functions of the human body. In the same way, these two elements support the physical aspects of IT infrastructure. However, these components shall be best discussed, described, elaborated, or explained through illustration, or shall we say animation, because for me, it will clearly show us how these components are interrelated to one another, or how the sub-elements of these components are complementing the functions of one another. In this way, it will give us a better picture on how the major equipment that falls onto each component are working all together to serve the function of the entire IT infrastructure. I will show that to you later, but first we'll briefly define what hardware and a network is. Hardware is basically everything that you can see when you face at your desktop or your laptops before you turn it on. It is the physical hard portion of your computer that you can see, that you can hear, that you can touch, or you can feel. In contrast with the software, as we all know, it is the digital portion of the computer that runs into these hardwares. The examples of hardwares are monitors, processing unit or CPU, keyboard, mouse, and other peripherals such as scanners, printers, webcams, CCTV, external storages, these earphones, or external microphones, and the like. There are types of hardwares that go beyond standalone computers. These may serve a specific function, or what they term it as appliance hardware, and runs without graphic user interface. Some of these serves as an external storage of a vast amount of data, such as servers, mainframes, and data centers. Some of these acts as a medium that links one computer to another computer or to many computers to facilitate communication and data exchange, such as hubs, switches, and routers. And some of these acts as an adapter that transmit signal from the web and connects it to your computer, such as the modem. And this will follow the definition of what a network is. A network is a set of computers, peripherals, storage devices, and networking hardwares connected to one another via cables or Wi-Fi to allow sharing of data and resources. The most common resource shared today is the internet, and it is a network itself by connecting millions of people all over the world. A network can be in its simplest form, like in our homes. We have a modem that receives signal from the internet service provider through links, namely coaxial cable or the wire that has a circular end, or DSL or the wire that has a jack same as the telephone, or the fiber, or the world's most recent technology that permits the fastest transmission of internet signal because it transmits signal through lights, whereas coaxial cable and DSL transmit signals through electricity. After receiving and decoding signals from the ISP, the modem shall then be connected to your personal computer or to your laptop using a networking cable called Ethernet. An Ethernet cable has a plug named RJ45. You can see this at the back part of your CPU that flashes color orange light. If you have multiple devices, you need a router to mediate, since a modem can only be linked to one computer, but a router can plug more than one Ethernet cable and can host Wi-Fi, which wirelessly connects to your laptop, cell phones, and other smart devices all at once, creating a small local area network. If we can remember school days, we went to internet cafes to play our favorite games or research the topics of our homeworks. An internet cafe is an example of a bigger local area network, wherein all computers therein are connected to a router or many routers depending on the size of the cafe, using Ethernet cables so that customers can play and chat to one another even without using the internet. Then if you have to print your homework, you need to send the document to a file server. Usually it is the computer of the cashier or the cafe's attendant, wherein this computer is connected to the cafe's printer.
This is what a basic IT infrastructure looks like in a typical business environment. The end users, who either employees or contractors of the company, will be using the system or will be using the applications installed on their computers. They will be interacting with a software through desktop computers or laptops that are assigned to them. The users will be using different application software pertaining to their department or the job role they are given. For example, the HR department would be interacting with HRIS to manage employees' time records. Accounting department would be interacting with this as well in order to extract time records for payroll processing. Then this transaction will be recorded on a separate accounting system intended for bookkeeping. Other than the desktop and laptops that the users are using, a typical company would also have heavy-duty computers called servers. These servers are also running software and are accessible by the users through a browser, and hence the term web-based application. And some of these software are not accessible by the users and serving some other purpose, such as batch reporting or auto-mailing. All kind of software are running on multiple servers on a typical company's IT environment. Actually, a company's IT room would have at least one data center rack that holds multiple servers, and the users connect to each server either through local area network or internet for a specific service. For example, that server could be to retrieve a website, to access data or email. A server could be dedicated to handle one of these services only, where you have one server for website, one server for data storage, and one server for email. Or you can also set up a server that handles each of these services in the same machine. So depending upon which setup is used, it all depends on the needs of an organization. For data storage, it would be very normal for a company to have one or more servers that are running databases. Databases are special software that manages data. In fact, some of the other software that are running on other servers would be directing to the database server to either retrieve a data or to insert newly entered data or to update existing data. In the case of employees' time records or accounting records, they are stored in a database server. Since all the departments of a company are interrelated to each other, the employees who are users of the computers need to communicate to each other to complete their daily tasks. The application server as well needs to talk to the database server to manage the data. The application server will have all the application related logic, but the data is residing in the database server. And the users are running hundreds of applications on their desktop, and they need to interact with these servers. Thus, we need a link that enables flow of data from one computer to another, and that link is called a network in the IT environment. And there are many hardwares involved in the network as well, such as routers and switches, and not simply a bunch of wire connected from one computer to another. What we have talked about is happening within the boundary of the company, or creating a local area network or LAN. But all companies now are interacting to the rest of the world through internet. In a typical company setting, we do have a firewall between the internet and the network of the company. This firewall in reality is represented by a combination of hardware, for example in the routers, and software like the Microsoft firewall in your laptops or desktops. Data traffic does flow between the company and the internet through the firewall in a secured manner that is filtering unwanted data that may cause serious damages to the company's IT infrastructure. For a business to thrive, it needs to be up to date with up and coming innovations in the market. Agility in collecting, processing, and storing information is the need of the hour, and the only way to meet this prerequisite is with the help of relevant technologies. Within a corporate IT environment, the terms virtualization and cloud computing are used interchangeably. However, they do not mean the same. Before pointing out the difference between cloud computing and virtualization, we will first define each. Cloud computing is the remote use of applications and features that are commonly used on a computer over the internet. Both data storage and server processing can be done from anywhere, everything being available on virtual servers. It will be possible to have a complete data center in another environment fully accessible via the internet. Personally, instead of storing your data or documents in USB drives, we can now keep our data in the cloud such as Microsoft OneDrive or Google Drive. On the other hand, virtualization is a software that virtualizes multiple hardware into one machine. This technological process can be summarized in the action of a software that creates a virtual infrastructure for a physical structure. It is a solution that enables you to run more than one operating system and different applications simultaneously on the same machine. So the main difference between the two concepts is that virtualization refers to the manipulation of software and hardware, while cloud computing is the consequence of this process. Cloud computing enables the business to share and make its data available to anyone, anywhere. For this, however, it uses software that has developed multiple virtual infrastructures from a physical layer, resulting in virtualization. Practically, cloud computing is a concept created from one product, virtualization. Another difference between virtualization and cloud computing is that in virtualization, you have a human being that needs to interact with a hypervisor to create virtual machines. You actually need someone or an admin to manually go in there and operate the virtual machines and to create whatever resources and networking properties that you need to have available in order for your virtual environment to function as needed. Whereas in cloud computing, you don't need an admin. There is an API or automated programmable interface that handles all the automation for communicating the hypervisor so that customers can self-consume the cloud products via interfaces available to them. In short, the human factor of managing the facilities or infrastructure has been automated with cloud computing. However, despite their differences and interdependence to one another, virtualization and cloud computing can work together simultaneously. And this will be the last part of this video presentation.
So the first thing you're going to start out is with a facility. So that's what this right here is going to represent. And then in our infrastructure, when it comes to communication, we need to have the ability to route that communication, and then the ability to secure that communication, and the ability to distribute that communication, right? So router, firewall, switch. And then from there, we're going to introduce how we typically would have bought some servers. So this is a traditional approach. Now, some of the challenges with this is these underlying resources are running at maybe 10% utilization. So we're going to introduce virtualization, and for each one of these physical, we're actually going to introduce virtual servers. And those virtual servers allow us to remove these two. Now, what we do is we can actually take the other components and virtualize those also on the same stack. And what this does is not only then make that super efficient, this underlying piece here, but it allows us to be very mobile, and later on we may do something with that to leverage that to solve other problems. How do we then enable the cloud to gain other value that we can for this environment? So what we do is we introduce all these resources here in the cloud, and what that allows is that when there's a seasonal need to allow this infrastructure to grow, or maybe a burst need, that we have the ability to take this and move it around inside the cloud here to make those resources really hum.